such as creating a data repository that doesn't depend on a particular type. The structure template example in listing 3-2 shows one such use. Listing 3-2, creating a template from a structure. Also include IO stream using namespace standard, template typing T, struct volume, T height, T width, T length, volume, height equals 0, width equals 0, length equals 0, T get volume, return height times width times length, T get volume, TH, TW, TL, height equals H, width equals W, length equals L, return height times width times length. Int main, volume, int first, C out, first volume, first dot get volume inline, first dot height equals 2, first dot width equals 3, first dot length equals 4, C out first volume, first dot get volume inline, volume double second, C out second volume, second get volume 2.1, comma 3.2, comma 4.3, inline, C out height, second dot height, inline, C out width, second dot width, inline, C out length, second dot length, inline, return 0. In this case, the structure contains height, width, and length values that the code can use to determine volume. The structure includes a constructor to initialize the values, so even if someone calls get volume, without initializing the structure, nothing bad will happen. The structure allows independent access of each of the data values, so you can set or get them as needed. The get volume function is overloaded. You can call it with or without input values. The code in main tests the structure thoroughly. Here's what you see as output for this example. Hi, Mason. Hi, Mason. Thanks for saying hi. First volume 0, first volume 24, second volume 28.896, height 2.1, width 3.2, length 4.3. Warning. You can use structures for another interesting purpose. The C++ standard says you can't create a typedef template. For example, the following code produces an error when you try to compile it. Template, type name T, type def, map, string T, my def. When you try to compile this code in code : blocks, you see the following error. Error template declaration of type def. However, you can define a type def within a structure template. The structure template 2 example code in listing 3-3 shows a variation of the example in listing 6-3 of book for chapter 6. Listing 3-3. Using a structure to define a type def. How should it include IO stream? How should it include map? Using namespace standard. Template type name T. Struct my def. Type def map string T. Type. Int main my def string : type merges. Merges Tom equals Susie. Merges Harry equals Harriet. C out merges Tom inline. C out merges Harry inline. Return 0. This example overcomes the C++ limitations by placing the type def within the struct my def. The same structure can hold any number of type def entries. Tip: using a type def in this manner makes it easier to work with map. All you need to worry about is the value type. The key type is already defined as string. Except for the merges declaration, this example works precisely the same as the example in book for chapter 6. It still outputs the following. Susie, Harriet. Developing a class template. Class templates perform the heavy lifting. Class templates perform the heavy lifting of the template types. You use a class template to define objects of nearly any size. Classes are larger and more complex than the other techniques demonstrated in the chapter so far. In most cases, use classes to represent complex objects or to perform tasks ill-suited for function or structure templates. Remember, you normally code classes in a separate file using the name of the class as the file name. The class definition appears in the header file, while the code appears in a code file. To make things a bit easier to understand, this chapter eschews the normal setup and shows the entire example using a single file. The example shows a specialized queue implementation. It includes many of the features of a standard queue, then adds a few features to meet special development needs. Queues and other containers tend to contain complex code, but you also need to use them with a variety of data types, making a class template the perfect implementation. The class template example in listing 3-4 shows the code for this example. Listing 3-4, creating a specialized queue. I have to include vector using namespace standard template type name t class my queue. Continued. Listing 3-4 continued. Protected. Vector t data public void add t const ampersand input void remove void print string void print int bool is empty. Template type name t void myQt ::add t const ampersand input data.push _ back input template type name t void myQt ::remove data.erase data.begin template type name t void myQt print string vector string iterator print it equals data.begin while print it does not equal data.end. See out print it inline print it plus template type name t void myQt ::print it vector int iterator print it equals data.begin while print it does not equal data.end. See out print it inline print it plus template type name t bool myQt :: is empty. Return data.begin equals data.end. Int main myQ.string equals myQ string q. See out string q dot is empty inline. String q dot add hello. String q dot add goodbye. See out printing strings inline. String q dot print string. See out string q dot is empty inline. String q dot remove. See out printing strings inline. String q dot print string. String q dot remove. See out string q dot is empty inline. My q int q dot add 1 int q dot add 2. See out printing ints inline. Int q dot print int return 0. The example starts with the class myQ. Note that the data is a vector, not a queue as you might expect. A queue is an adapter. As such, it doesn't provide support for many of the features found in containers, such as vector, one of which is the use of iterators. Remember, this example uses an iterator for printing, so it relies on a vector, rather than a queue as a starting point. Whenever you create your own specialized version of a common construct, make sure you begin with the right object. Otherwise, you might find the experience of creating a new class frustrating, at a minimum, impossible in the worst case. MyQ includes the capability to add, remove, and print elements. In addition, you can check whether a queue is empty or full. You have already seen the code for these tasks in other parts of the book. You might wonder about the code used for printing. The example includes separate methods for printing strings and integers. Some might seem counterintuitive. After all, why not simply declare the iterator as follows so that it accepts any data type? Vector t print it equals data.begin. The problem is that the iterator requires a specific data type. Consequently, you must declare it as shown in listing 3-4. Otherwise, you get this unhelpful error message. Error expected semicolon before printed. At some point, you want to test this new class using steps similar to those found in main. The test checks whether the queue actually does detect the empty and build states, how adding and removing elements works, and whether the print routines work. Here is the output from the example. 1. Printing strings, hello, goodbye. 0. Printing strings, goodbye. 1. Printing ints, 1, 2. Considering template specialization. Some templates don't go together quite as easily as you might expect because they express a concept that doesn't translate the same way for every data type. For example, when you use stringify to turn a data type into a string representation, the technique differs based on data type. For example, when you want to use stringify on an int, you might use the following template as shown in the stringify int example. Oops. Wow, I put on the green screen by accident, but I don't know how to make it go away. You used to be able to just turn it right off. Well, alright. Concerning to my specialization. Oh, yeah. Woo. For example, when you want to stringify on an int, use stringify on an int, you might use the following template as shown in stringify int example. That's so weird. You used to be able to. Okay then. Well, that's not helpful. Okay, that's crazy. Well, okay. How to include stream? How to include stream using namespace standard template type name t inline string stringify const t ampersand input. O string output. Output. This is much easier to show. But I can't show. How do I stop? Alright, I'll just close this one down and put in a new one. That's so weird. You shouldn't have to close the stream down just to get the green screen to go away. Okay, be right back.